Viewers, I also got this dual charger from work as well. The bloody thing just stopped working. Just got a new one since, but 2013 this thing was made. Didn't get very much use out of it. Only about nine months. So it shows how long it's been dead for. 13th week or 39th week 2013 it was built. But the design, TTI, the company that designed this, patented this circuit board on the 14th, 2012. Lithium ion or NiCad. This is why I like the good old style linear power supplies. Why couldn't they have made a smart linear power supply for lithium ion batteries? As soon as I bought lithium ion batteries out, they make the chargers out of shit. But the batteries this time last forever, or seem to last forever, but the chargers don't. But with the old shitty batteries, we got a good quality linear charger which seems to last forever. But these newer batteries, it's the other way around, your charger buggers up. Pathetic dogs. Now I plugged it in and did some tests. That capacitor stays charged. This seems to work, this transistor. I tested good in the multimeter. So something is not discharging that capacitor, slowly draining it down. So I checked these resistors. This thing's got a bit of the outside chipped off it. It aimed up, but didn't continuity test because it's a resistor. Continuity only works when it's a dead short or a trace. Well, maybe still want to replace it anyway, just in case it is open circuit. And we'll start with that one. It just seems to want to do something. So if that has to, how's that going to work? That resistor's going between one of the legs of the transistor. That third leg of the transistor has to go through this resistor before I can switch that transformer. So I'm guessing it's not switching this transformer because this resistor could be open circuit. The first leg, looking at it from this side, has to go through this resistor, then to this transformer. So we'll check this resistor. It looks like this isn't getting fully driven. Because if it was getting driven with nothing in it, I should have a red light. And that's it. But I'm not getting anything, so I'm going to check this resistor. Okay, I got the this is the Ryobi ONE Plus battery charger, by the way. Look at the overall design of the circuit. It uses Capxon brand capacitors, which are all fine on this one. There's my botched in resistor. I couldn't get it to fit on the top. Too much of a tight squeeze. And those leads would have touched the heatsink and shorted it out, so you don't want that. We have some spark gaps. Primary and secondary are clearly separated here. It says on the board. I quite like that a lot. That's a quality power supply. You can see this circuit board it's made of. Real quality. That's how switch mode power supplies should be made of. They're the type of circuit boards you would look for. There's some spark gaps. You've seen Dave Jones and EEV blog put those things to the test. Basically, if you get a power surge through your mains, it's going to have to jump those spark gaps. And they help to take out the bang, or the current from the spark. You get a jump from there to there, and the MOVs will take the rest for protection. So it's good to have those little spark gaps in there. Primary, secondary, primary, secondary, primary side of the transformer, secondary side. This is all secondary side here. I like how they've clearly laid that out. But we've got some switch mode power supply with a lot of surface mount components, so hopefully none of those components are damaged. The Ryobi ONE Plus charger. Now when I plug it in, that light should flash red when the charger's in standby. Let's give it a test. I'm going to plug it in now. Hopefully we're going to get activity. No. Still no go. Alright, might have to check capacitors. They might not visually be bad. I don't hear nothing. Not even the slightest switching, hissy or chirpy sound coming out of that thing. There is power on the primary side. The capacitor charges up. Let's go see if we've got the voltage despite there not being any lights. Nothing there. Negative. positive. Nothing. Not doing nothing. Nothing at all. Alright, needs more troubleshooting. Hope it's not a surface mount component over there that's gone bad. Alright, unplug safety first. Now a good power supply doesn't hold charge on the pins. The bloody charger for this camera, when I do this, I get a nice bang. So that's not supposed to happen. Discharge that capacitor. .400 was in that at 68 microfarads. Give you a hell of a kick, I tell you. I gotta check these generic capacitors then. I'll start on this side of the board. Maybe they've just got open circuit but I can't visually see that. We've got like a shunt resistor. When the battery charges, this thing acts as a ballast. I can't see any physically damaged components. There's a bit of nasty residue on them, like a solder mask residue. It was poorly cleaned. Alright. Yeah, keep checking those. Alright, capacitors I'm going to check next. Now it says it's definitely a 43 ohm resistor. Checking the colour codes on Google confirms that. You get it tested over 200 ohms, so that was definitely way out of tolerance. 47 ohms isn't too bad off. Yeah, more fixing up on this one. Anyway, that'll be enough for now. Thanks for watching.